Hi, this is an optional video to help explain the MAD, or the mean absolute deviation. Before I go into the mean absolute deviation, I'm going to spend a few minutes reviewing the mean, or the average, of a data set. In this video, we'll be looking at these two made-up data sets. Each one of these is supposed to be a made-up class of 10 students. So these are 10 students in a class, and these are 10 students in a class. And the graphs are showing their exam scores. So these are the exam scores of the 10 students in this class, and these are the exam scores of the 10 students in this other class. In this class, 6 people got 75s, 2 people got 70s, and 2 people got 80s. In this class, 1 person got a 60, 2 people got 70s, there were 4 75s, 2 people got 85s, and 1 person got a 90. So let's calculate the mean exam score of this class and the mean exam score of this class. To do that, we just have to add all of the numbers in the data set and then divide by the number of numbers. That gives us the mean. So let's find the mean of this first class. To find the mean of this first class, we need to add their 10 exam scores and divide the total by 10, because there's 10 of them. We'll do that on the board right here. If I add these 10 exam scores, the total will actually come out to 750. And to get the mean, I have to divide the total by 10. I have to divide the total by the number of numbers. This one comes out to 75. So the mean of this first class is 75. I'll label the mean right here. It makes sense that the mean would be 75 because remember that the mean falls somewhere in the center of the data set. Now let's find the mean of this class. We just have to add their 10 exam scores and divide the total by 10. Just like we did for the first class. Actually, I'm going to need to move these two over here. So we'll have 80, 80, and then 90. I'm doing that just so that the mean comes out to a nice number without any decimal points. I'm also doing that so that the mean of this class will be the same number as the mean of this class. So these two people got 80s. So we have 160, should be 2 70s, 4 75s, 2 80s, and a 90. If we add these, they actually add up to 750 again. And since there's 10 students, we have to divide the total by 10. and then we'll have the mean exam score of the class. So just like the first class, the second class has a mean exam score of 75. And once again, it makes sense that the mean is 75 because the mean falls somewhere in the center of the data. And we can see that these two classes both have a mean of 75, but the two classes have different amounts of spread or different amounts of dispersion. The exam scores in this class have lower spread or lower dispersion because they're closer together. The students have more similar exam scores, and everyone is pretty close to the mean. The exam scores in this class have higher spread or higher dispersion because the exam scores are spread out across a wider range, and there's some people who are pretty far away from the mean. Let's think how we can actually measure the dispersion of these two classes. One way would be with the range. The range is the most simple measure of dispersion. The range is just the highest value minus the lowest value. So to get the range of this class, we would just subtract the highest exam score by the lowest exam score. It would be 80 minus 70. We would have a range of 10. Over here, we would do the same thing. To get the range of this class, we would subtract the highest value by the lowest value. It would be 90 minus 60, and we would have a range of 30. So this class with a higher dispersion does have a wider range than this class with a lower dispersion. In this class, the highest and lowest values are 30 apart, and in this class, the highest and lowest values are only 10 apart. There's actually a different value we can use to measure dispersion besides the range, and it's called the MAD, or the mean absolute deviation. First, I'm going to show you kind of a shortcut way of finding the MAD just by using the graph, and then I'll show you the way I showed the MAD in the video, in last week's video, with the columns of numbers. The MAD is really just the average distance to the mean. Each of these values is a certain distance from the mean of 75, and the MAD is just the average of all of those distances. If we want to get the average distance, first we have to find out what all the distances are. Well, all of these exam scores are 0 away from the mean because they're all equal to the mean. So I'll put a 0 next to all of these, showing that each of these exam scores has a 0 distance to the mean. These two exam scores are 5 away from the mean because 70 is 5 away from 75. So this exam score has a distance of 5. This exam score also has a distance of 5. This exam score of 80 is 5 away from the mean of 75 in the other direction. So I'll say it has a distance of 5 from the mean. This exam score is also 80, so it also has a distance of 5 to the mean. Now I've written out the distance from each exam score to the mean. I've written out the 10 distances. To get the MAD, all we have to do is just get the mean, or the average of those 10 distances. So let's do that. The distances are 5, 5, 0, there's 6 zeros, 1, 2, 3, 4, 5, 6, and 2 more 5s because of the 80s. Now let's get the average or the mean of those distances. They add up to 20, and we we'll divide by 10 because there's 10 numbers in here. There's 10 distances. And it looks like the average distance to the mean is 2. So this first class has a MAD of 2. The MAD is just the average distance to the mean. Now let's find the MAD of this second class. We can see that the MAD is going to be higher because this class has higher distances than this class does. For example, this person right here is, 60, 75. This person who had an exam score of 60 is 15 away from the mean of 75. 60 is 15 below 75. This person who got a 90 is 15 above the mean of 75. So this person has a distance of 15. And these two people who got 80s are 5 from the mean, just like these two 80s were. So 5 and 5. These two 70s are 5 below the mean, so they're 5s. And these are exam scores are 0s again because they're equal to the mean. So we do have some 0s in here, and we do have some 5s, just like we did in the first class. But we also have these two 15s. We have these two bigger distances, and these two 15s are going to bring up the average and cause us to have a higher MAD. And let's look at that to see that happen. So we're going to let's calculate the MAD of this second class. I just have to free up some space. So in this class, the distances to the mean are 15, 5, 5, and then 4 zeros. Two 5s, and then a 15. So these distances are going to add up to a bigger number than they did over here. Here they added up to 10, but now they're going to add up to something bigger. Let's see, 25, 25. They add up to 50. And when we divide 50 by 10, we get 5. This class has a MAD of 5. So in this class, the average distance to the mean was 2, and in this class, the average distance to the mean was 5. When the data set becomes more spread out, you have bigger distances to the mean, and those bigger distances bring up the average distance to the mean, and you get a bigger MAD. So that's pretty much how the MAD works. As the data gets more spread out, you see values that are further away from the mean with bigger distances, and those bigger distances bring up the average distance and cause the MAD to be higher.